The integral of this then, we need to show that this, it says by first dividing out. So these examples you split the fraction up. So we're going to do these questions by first dividing out. But then we're going to move on and finish off that example at the end of this vid. The example 3 that we missed out in the previous section. So let's do the first one then. So I'll call this I. So I equals then. When you split up a fraction, 3 plus 4 over 9, you can write the first term over what's underneath, plus the second term over what's underneath. So we do the same thing here. The first term over what's underneath, plus the second term over what's underneath. There's just an x here. I've managed to write an x squared. That's it. So an x is cancelled and it's just 2x, isn't it? So I'm going to scratch this now and write 2x. Save me writing another line. So now we can integrate. Let's have a go. 2x raised to the power by 1 divided by that number. Minus, and this is an integral log x plus k. And the 2's cancel. So it does equal the x squared minus log x plus k. Now let's try the next one. Here we can write x minus 1, can't we? Remember how we did that in the previous section in the examples? I equals then. Now we can write x plus 1 as x minus 1, so that it's the same as what's underneath, but then we'd need to add on 2, wouldn't we, to get back to plus 1. So we're not changing anything. We're just changing the form of the problem. So this is the first term over what's underneath, plus 2 over what's underneath. Which, these now, in this form, we can integrate, can't we? Because this is just 1. So I'm going to scratch that and just write 1 here, if that's okay. Save me writing a fresh line. So the integral of 1 then is x. And this is a standard integral. It's 2 lots of log x minus 1 plus k, which is what we wanted to show. Now let's move down to that problem in the examples that we missed last time. Here, so we'll label this as I. Now, we said we're only going to do proper partial fractions. This is of order 1 on top. The highest power is of order 3 underneath. So it is a proper partial fraction. It's a rational polynomial. And it's proper in form. But this is not a linear factor, is it? Because it's quadratic. But you'll notice that 4x minus 1, 4x squared minus 1, it's a bit of a cheat this, because you can write 1 as 1 squared. And you can actually write the 4x as 2x squared minus 1 squared. And this is a standard form that's known as the difference between two squares. I think I mentioned it in quadratics. If you have a squared minus b squared in form, you can split that up into factors of a minus b times a plus b. So once you recognize that this, 4x squared minus 1, can be written as this, then you can see that it corresponds to this in form, the a being 2x and the b being 1. So you'd get 2x minus 1 and 2x a minus b. B is 2x minus 1 and 2x plus 1. That's it. B is 1, isn't it? And a is 2x. So it's 2x minus 1 and 2x plus 1. So that's what we can do here. So right at the outset of the problem then, we actually wouldn't even write that down straight away. And even if we did, on the very next line, we'd just do the difference between two squares. 8x minus 1 then over x. 2x minus 1, 2x plus 1. Now we've got linear factors underneath. With linear factors, we use the method of partial fractions. So 8x over x, 2x minus 1, 2x plus 1, will equal a over the first linear factor, plus b is the same method, in principle, over the second linear factor, plus c over the third linear factor. Multiplied by the denominator then, and see what we get. We get 8x on the left, and here it's just like multiplying by these two by a, and then b gets multiplied by this one and this one, and c gets multiplied by this one and that one when we're creating a common denominator of these three factors. This is what happens. Okay, so now we need to substitute convenient values of x. See, if we put x as 0, those two will disappear. We'll get 0. And here we'll get minus 1 times plus 1 is minus 1 lot of a. So a is 0. This would be 0 and this would be 0 here, wouldn't it? X is equal to, the next value is a half. And then we'd get 8 halves of 4. A half in here would be 1, so that would go. And a half in here would be 1, so that would go. So it just leaves this term here. So 2 halves of 1 plus 1 is 2, so that's 2. Times a half is just 1 lot of b, isn't it? So b equals 4. So the other convenient value now is to put in minus a half, isn't it? What does that give? Minus 4 here. Minus a half, this will disappear, and so too will this be 0. So you're only going to worry about this here. So this would be minus a half, and this would be minus 1 minus another one is minus 2. So you'll get c. 2 times half is 1. Minus times a minus is a plus. So c equals minus 4 then. So we can write down the answer now. I equals then the integral. It will be, instead of this stuff, it will be a, which is 0. So b, 4 over 2x minus 1. Plus b, c rather, minus 4. So put a minus in then. Over 2x plus 1 dx. And we can work that out straight away, can't we? That will be 4 ln 2x minus 1. Remember the 1 over a, there's the a, so you get over 2. Minus 4 ln 2x plus 1. Over the a number, so that's a 2. Plus k, so that's equal to, then just tidy it up, 2 ln 2x minus 1. Minus 2 ln 2x plus 1 plus k. Now I've done that example. The clever thing was I've decided to change my problem. See, I've wrote down the original problem accurately, but then I did 8x, which is an actually easier problem. So I still haven't done example 3 in the notes, but I've done an example here that's very, very similar. So you could perhaps try the 8x minus 1 example in the notes then. But this problem I've done here as an example, it's just the same in principle. It's no different. But I managed to just write down my problem here and get it wrong, so I'm changing my question, which is a good thing to do. Okay, that's that question 1 then.